we're going to find the interval of convergence of this power series. Now, it's important to recognize a couple things here. This power series has an x part of it, okay, just like some other power series that we've done has an x part, but this one also has the n part to it as well, okay, the Sn part. So this is not the simple power series that we had looked before. It's a little bit more complex, but still it's a power series, and we're going to find the interval of convergence for this. Okay, so to test the interval, we want to use the ratio test. So our ratio test is going to look like this. The limit as n approaches infinity, we have our an term. Okay, so that's going to be, or that's going to an plus 1, so 10x to the power n plus 1 over n plus 1 factorial. And in the denominator, we're going to have 10x to the power n over n factorial. And this ratio test, we're going to check to see when it's less than 1. Now, because we have x's in there, we can change the value of x to make it less than 1. So I'm going to then rearrange this. So I get limit as n approaches infinity. I'm going to simplify this complex fraction. So we have 10x to the power n plus 1. So I'm going to write that as 10x to the n times 10x. That's where the plus 1 is coming from. In the denominator, we have 10x to the power n. That's going to get grouped together. That's going to represent the x part of this, this ratio test. For the n factorial part, we're going to have n factorial over n plus 1 factorial. Okay, so n plus 1 factorial, I'm going to rewrite as n plus 1 times n factorial. Okay, so I'm going to group that together. I'll do that in red. And that all must be less than 1. Okay, so lots of things are going to cancel out here. We have 10x to the power n's cancel out, n factorials cancel out. So we end up with this limit, the limit as n approaches infinity of 10x over n plus 1. And this needs to be less than 1. Okay, so in this case here, if we let n go to infinity, the denominator is infinite. X, although x can change, x is a finite number in the domain. So regardless of what happens here, n plus 1, as n goes to infinity, is going to outgrow the 10x. And so this is always going to be equal to 0. So the limit, this becomes 0 times 10x is less than 1. Well, this happens for all x's. So this occurs for x's for all real numbers. Okay? Now, we did talk earlier about the center, so there is no horizontal shift. So when we talk about the center is at 0. The radius is based on this ratio test. The radius happens to be all real numbers for this case. So this is kind of the nice case when the radius is infinite. Okay, and then our interval becomes all real numbers. And we could write it as in the interval notation like that.